Dr. Pantalony is the Curator of Physical Sciences and Medicine at the Canada Science and Technology Museum in Ottawa, and he used his museum's collection to teach artifact-based seminars as adjunct professor of history at the University of Ottawa. Dr. Pantalony received his PhD from the University of Toronto and completed postdoctoral fellowships at the Smithsonian Institution's National Museum of American History and at MIT's Dibner Institute. Dr. Pantalony has published 2 books related to the history of scientific and medical instruments. He is chair of the History of Physics Division of the Canadian Association of Physicists and is a member of the editorial advisory board for the Journal of the Canadian Science and Technology Historical Association. His visit here today is sponsored by the Canadian Centre for Nuclear Innovation at the University of Saskatchewan. And the title of Dr. Pantalony's address is Made in Saskatchewan, Nuclear Medicine Innovation and Impact. So Dr. Pantalony, welcome. Thank you. The mouse is just under there.
Okay, great. Thank you, Joan, and thank you to the Canadian Centre for Nuclear Innovation and the University of Saskatchewan and the Western Development Museum for inviting me today. It's a great honor to be speaking in front of such distinguished guests and in front of you, the public. And so I hope I can shed some light on today's event in a different way. And I also want to say it's a great honor to represent my colleagues in Ottawa at the Canada Science and Technology Museum. We're the national depository for things related to science and technology, and it's a great honor to represent them here before all of you. I wanted to start today with an artifact that I found in the basement of the physics department at the University of Saskatchewan, and there's just a little snippet of it. It's part of the Weaver X-ray machine, the first one on the prairies in 1904. And it's actually not an unusual artifact. Even in the early 1900s, there were X-ray machines floating around, so you find them in museums, so it's not uncommon. But what is uncommon about it is that I found it in the basement of a physics department. So, and I think this speaks to one of the themes today, and that is that even early on in the history of the physics department and the University of Saskatchewan, there were people who were committed and actively interested in medical physics. And I think the story of this one is that it probably was brought in by Earl Harrington in the 1920s before they went to some of the radium experiments and high voltage experimentation with therapy. And this was probably used more in a therapeutic context. But I just think that, again, some of the things I found there speak to patterns that I'll be telling you about today that I found in the collection there. So one of the reasons I've been here 3 times, it's been a great pleasure to visit Saskatoon 3 times in the past year and a half. And one of the reasons I came here, and I have been coming here, is that this place was and is and will be a powerhouse in physics and medicine, and especially in the 1950s. And that keeps drawing me here, and especially in the physics department, where they have this illustrious history. And so I've been drawn by this question, and I think Dr. Houston addressed this question brilliantly in his book, Steps on the Road to Medicare. Why Saskatoon? So this is all obvious to everyone in this room, but when I tell people that Saskatchewan was a powerhouse in physics and medicine in the 1950s, they're always surprised. And I'm even getting tired of them being surprised. But not physicists and medical people. They aren't surprised. You'll hear from physicists from that time period and even today, well, the Soviet scientists in Siberia were reading and hanging, waiting to hear from what was going on in Saskatoon in the 1950s. And that's for real. This was a powerhouse. So that's the big question that I'm interested in, and it's still sustaining me, and I love coming here for that. And I don't want to belabor some of the things that you all know about the why of Saskatchewan in that period, but I just want to kind of address them quickly before I get into the reasons that I've come up with. And one of them is in Dr. Houston's account of Steps on the Road to Medicare, and he talks about with this remarkable account of Tommy Douglas approving the Cobalt-60 machine with one visit by Harold Johns and Alan Blair. So I think there's something in that of this kind of executive authority and vision implemented through Tommy Douglas. So there's definitely, you can't avoid Tommy Douglas in this whole story. Also, in Bill Waser's magnificent History of Saskatchewan, which I love, you have really a portrait of a province at that time with this incredibly progressive and experimental government. And I think that is another aspect of this story that really, he even talks about people coming from around the world to work in the Saskatchewan government because it was renowned for these experiments and for its progressiveness. Obviously, some of the guests here today will know that in physics, there was some incredible talent in Saskatoon at this time in Saskatchewan. Gerhard Hertzberg, who won the Nobel Prize in spectroscopy, was in the physics department. Earl Harrington, Harold Johns, Dr. Fedorik. In atmospheric sciences, which it continues to be a powerhouse in, you had Balfour Currie and that whole group in the meteorological and atmospheric sciences. So an incredible pool of talent. Obviously, I don't need to tell people in this room about Medicare, about how this province paved the way. And again, Dr. Stewart addresses this in his book and about the communitarian spirit being part of the context for that. And his great quote here at the end of his book, "The seeds fell on fertile ground." And I think that really speaks to a lot of what I'm talking about here. And then things that have fascinated me because I love the arts. There was a great moment here in the 50s and 60s with the Emma Lake group, the Painters Workshop, and the famous people that were coming here like Barnett Newman and the Regina Five. So, for me, this is a Toronto boy. This is quite a fascinating place. And I've been really fortunate to come here and discover new things. So I wanted to talk about that. One thing that I do, I'm a historian of scientific instruments. So I'm kind of an Indiana Jones of physics departments. I go around throughout Europe and North America. I've kind of explored physics departments and their historic collections, a lot of them uncatalogued. And some of them, physicists even call them junk. And what I do is I try and see what those objects tell us about the history of science, the history of that university, the history of research there. And it was to my great astonishment that I discovered quite a collection in the basement of the physics department, which is kind of the basis for what I'm going to tell you a bit about today. And some of those things added to, complemented, even challenged what I just presented to you about the reasons of why this was a powerhouse. And I just wanted to share a few of those findings, surprising findings from the collection and what it told me about Saskatchewan in this time that I think feeds into our celebration today. And this was the first one, the first theme that I want to talk about and pattern is instrument making. So this is interesting. I found objects like this. It turns out that this one from the early department, and really this is incredible. This is the early years of the department, 15, 20 years after this place is a province. And you have here a Wilson cloud chamber made by a guy named F.W. Pye. Now no one in this room, I'm sure, knows who F.W. Pye is, but I know who he is. He came from the famous Cavendish lab in England, where all the top physicists were trained, and everyone went there as a pilgrimage in the early 20th century. And why was Pye here? That was amazing to me. Well, it wasn't so amazing when I found out some of the history that even early in this department of physics, they valued and prized top mechanics, skilled machinists, and instrument makers. And so I started seeing through the collection a real value and tradition and history and pattern of skilled instrument making in this department. So right away I'm thinking this is interesting. Turned out one of Pye's brothers was at McGill, working there with some of Rutherford's colleagues in a special time there in the history of physics. So this is, in fact, a really interesting thread that goes through the collection throughout the 20th century, as I found in the archives too. There's all these important instrument makers that were in the University of Saskatchewan. And the reason why I want to highlight this is because instrument making is one of the most underrated sources of creativity and change in the sciences. And you know, this is interesting because what I've done is I go around and I look at various places in the history of science, and you see patterns. And one of the patterns is wherever there's been a hotspot of innovation, there's been really good instrument making. So one of the top historians of science, Larry Stewart, is right here in University of Saskatchewan. He's actually an expert on 18th century London, which was a really powerhouse of its day, and the amazing instrument making, the technologies, the skills, the training, the materials, and all the cross-fertilization of industry and research at that time. And so I call it a knowledge ecology, not a knowledge economy, a knowledge ecology, because you have all these interesting things being traded in this world at that time. I myself have done a lot of work on another 19th century place of innovation, Paris, and the instrument makers there and their role in innovation there. Other places like Minneapolis, Medical Alley, mid-20th century up till now, you have the same story, and here. And what's really interesting about here, you can go through all the interesting instrument makers, but here we have the story of John Mackay. And I think, again, it's not in a vacuum. Obviously, John Mackay was a really skilled person that was able to implement a difficult project, and not only that, but commercialize it working with Picker in the United States as they went forward with that project. So I think, obviously, instrument making and those skills have had a massive impact on this local on knowledge economy here. Now, some of you will be thinking, with this picture, what is this weird guy from Ottawa showing this crummy picture of an old beat-up machine from the physics department? And, well, actually, it's quite significant, not in the history of physics research, but physics teaching. And this is the next theme I want to talk about, a pattern that I saw in the physics department. And that is, there was a lot of instrumentation that pointed to an active, creative effort and strong commitment in teaching. So this object is actually quite difficult to make. It was homemade here. Most collections, like say Harvard that I've gone through, all these things would have been bought. Here, it was made. And this would have taken some calculations and a lot of effort to make. And I think, again, like other things in the collection and things I found in the archives, I found this very creative, strong commitment to teaching. And I think this speaks to that. And I think that this kind of commitment fell into a welcoming context here. You had things that I've discovered here that many of you know about, like the Physics Club. And this was a community in the physics department of sharing, and Dr. Fedorik would know all about it. But this is a really interesting group, and I think it speaks to partly the teaching and the communitarian spirit here in University of Saskatchewan and how the two were combined. And I think Dr. Fedorik, for example, is a real embodiment of that with her public service and her scientific career. And really, what's amazing is that the careers of all the students that came from this department speaks for itself. It's incredible when you see a lot of physics internationally and in Canada, how many roads lead back to undergraduate training at the University of Saskatchewan. So one person in particular, Dr. Fedorik's colleague, Ed App, for example, went to Harvard. So, and you have that kind of story continually. One I just found out recently was the renowned meteorologist, William Middleton, was here as an undergrad. So it's incredible how many people came through here, and I think that the careers that came from here speak for that, the impact that was made from the teaching and the commitment here. The other thing I just wanted to point out, speaking of teaching, part of the physics club seemed to be part of it, that kind of culture, was this physics museum. Now, this wasn't a museum like a cultural museum like this. This was a museum, again, for learning and sharing and demonstrating, and this artifact is from that, and I found a number of these in the collection. And what was interesting about this is my colleague at the Smithsonian, Steve Turner, has discovered a very similar physics museum in Chicago Physics Department at the same time in the 1930s. And I think there's some emulation going on, and that speaks to the next point that the next theme I wanted to raise. the other theme that seems apparent when you're going through the collection and the history here is a surprising one for me, because a lot of the places I've studied, you're looking at east-west axis. So London to Toronto or Montreal, or this type of east-west. But here you had east-west influence, but also north-south. And I think that really should be explored some more. And here we have one of the original Betatron tubes that came from Dr. Kirst's laboratory in University of Illinois that Harold Johns picked up when they first went on their investigation south. But this is, again, not just one incident of this north-south axis. You have really a strong tradition in the department of working with Chicago. Harrington actually trained in Chicago with Milliken. And you have Hertzberg, who had a Chicago connection too. So there's a lot of interesting Chicago connections as you go through, and Milwaukee with the actual Betatron. So I find that's something, and also Harold Johns and the team actually teamed up with Picker in Chicago, and the London team went with Chalk River and AECL at Atomic Energy Canada, which so you have those two different kind of forks in the road. The other connection I wanted to raise is some of you will see the AC there, and this has been mentioned a bit today already, but that's Alice Chalmers from Milwaukee, and Dr. Houston mentions this in his book too. It is interesting that was an agricultural manufacturer, and again, this is another sub-theme running through this, and that is the rural connections that they went to, and Harold Johns went to an agricultural manufacturer to make this Betatron. And Dr. Fedorik mentioned, how much of John Mackay's stuff is in this museum potentially. And again, I don't think that's a trivial matter. I think there is a connection between the rural roots of many of the instrument makers and physicists and engineers and the medical technologies that were made. And that's very interesting, and that's why it's so fitting to be here today, making that loop between medical technology and agricultural history. I just wanted to mention something else that was mentioned in the video about the race between London and Saskatoon. Dr. Houston mentioned the calibration of the dosages. And again, I don't think that's a small matter. I think it's worthy of a lot of historical scrutiny in itself, because one of the big legacies that came from this project and the work Dr. Fedorik performed was of safety and precision, and that really marks, I think, a juncture in radiotherapy. When you have this gamma source, this very powerful source for the first time being used, but being used responsibly with great precision and safety. And there's something going on here. There's a pattern in these early years of boldness, of taking a new technology and implementing it quickly, but also of the spade work and the kind of systematic working through of a problem. And I think there's a lot of beauty in the processes of that, and I think that should be celebrated just as much. Well, now I just want to move into my conclusion by pointing to the future. Now, some of you, again, will be thinking, this guy from Ottawa is crazy, showing a 1920 multi-prism spectroscope to talk about the future. But I discovered this in the basement of the physics department too, and it really struck me as interesting because, again, the beginning of a department without much money, and for those of you who do know, this is a very expensive apparatus from that time. It would have been the equivalent of more than a professor's salary for a year. And it shows, again, a commitment and a high value being put on optical research even this early in the department, and a tradition of optics here going back to 1920. And I think this is a nice way of really moving to, you can move through Hertzberg and the spectroscopy and the optics research. You see this again in the collection, and then right up to what's going on today with the light source. And this is really nice for today because, again, you have this artifact that takes us through the optical history of and spectroscopy to the light source, which is now dealing with both medical isotopes and the nuclear medicine, the medical physics aspect of this, and with the light too. So it's kind of both combined in one, and my colleagues here will be talking about that aspect of the future. I just want to say about what I'm excited about, my dream in the next few years, I hope in 2 summers, to bring graduate students and faculty from across the country to descend on the campus here to do even a bigger kind of form of what I've been talking about today and really explore the history of this campus. Every year we have an annual Reading Artifacts workshop at the National Museum where we have graduate students and faculty from many disciplines come to Ottawa and explore, engage in our collections, and it's a really fun, productive week that we have in August. And I was hoping with all the great collections here and the great history to really blow the lid off University of Saskatchewan and bring all these people internationally too to the campus to explore these in the collection in new ways and really highlight what's going on here and what has gone on here. And so just wanted to point that out, that I'm excited about that. It's one of my dreams. And finally, we're here to celebrate great science and scientists and physicians, but I also wanted to celebrate the people who preserve and preserved all the primary sources that we've all been talking about. And it's not just for the sake of nice history that you can see on a Sunday afternoon, but some of the themes I've been talking to, I think, are really relevant to science policy. And when we talk about innovation, there's 2 ways we talk about it. There's the meaningless buzzword innovation that many of us use. I use myself, but then there's the meaningful one that is what a colleague of mine in Quebec, Yves Gingras, calls evidence-based science policy. And I think you have something unique here. You have a unique history. I think that using the patterns and the documents and the preserved documents and photographs and artifacts, I think can speak to how to go in the future. And I hope that the people who preserve this will be celebrated as much as the people who created the actual primary sources. So thanks very much.